Hi there, welcome back. Time for a new project, and this one is going to be one hell of a challenge. This is not one of the normal Grundichs, Telefunkens, whatevers that I've done on here. I really like those brands, I really do, but there's one brand in the German lineup that beats them all, and that to me is the SABA. I know I'm a Braun fanboy, I've admitted it quite often, too often. But the SABAs, to me, really take the prize as the best designed radios from the 50s and even the 60s. And you'll see why. Now, this is not the first time I've done a SABA. In fact, I've done 4. I've done a Freiburg 8. I've done 2 Meersburg W3s. And I've done a Freiburg W2, I think it is. And I've actually done a Willingen something. But this one is something I bought more for the experience than for the result. And the reason is this radio is not complete. This thing is sitting at the back here and it's only the chassis. This radio comes out of one of those units with gramophone and legs and wood and all that stuff, you know, a piece of furniture, you put them in your lounge. This thing came out of one of those. And the only thing that was for sale was the chassis itself. So it's got no speakers, but it's got everything that I want to work on that is very typical of the SABAs. Unfortunately, this thing came to me with the dial glass broken, which is not unusual. I mean, this thing weighs about 15-20 kilos, so it is not unusual that in shipping the dial glass breaks, which is a problem. Now, fortunately for me, it wasn't a bad break. I might be able to repair it. If I can't, I really don't know what I'm going to do. But I'm going to do the restoration anyway. Before we go on, I'd like to invite you to visit this video's sponsor, PCBWay, who are a true one-stop PCB prototyping company supporting all types of available PCB services, including standard PCBs in a variety of cool colors, advanced PCBs, flex PCBs and more. And they also provide a PCB assembly service, which includes design with their PCB design service. And the price is $5 for 10 boards and build time of 24 hours. You can't go wrong. So visit them, you won't be disappointed. I've got to warn you, I'm not going to do this as a continuous project. So it's going to be quite a long series because this radio deserves it and it needs it. This will probably be something that'll be quite spread out. So don't be surprised if we go for quite a bit of break between the videos. What I want to tell you about this radio is that it is from the real golden era of the 50s radios. It comes with automatic tuning. That's why this thing is called a fully automatic. And I found the same system on the Freiburg 8, which I've restored quite a while ago and before I started doing videos actually. So I have no footage of that. It's unfortunate because the Freiburg is actually the top of the line of all these sets. Now, SABA used to come out with sort of a model every year or every couple of years. And whenever you got a model, you got 4 or 5 of them. You'd have the Freiburg. You'd have after that and lower in price, you'd have the Meersburg. After that and lower in price, you'd have the Freudenstadt, then the Wildbad, and I think there's probably 1 or 2 more. Now, just to give you an idea, this thing's from 1957-58, hence the 8, Freiburg 8, Meersburg 8. This one is the Breisgau 8. And what it is actually a Meersburg 8 chassis that was used in this Breisgau unit. So effectively, we're looking at the second tier in quality and price from the series for that year in terms of radio itself. The Freiburg 8 that I just talked about, that's the top end and it's from the same year as this one. Now, a lot of the circuitry is very, very similar. The Freiburg and the Meersburg were both automatic. I think the Freudenstadt and Wildbad were not. Now, just to give you an idea, the Freiburg 8 was sold at that time for 6.99 D-Mark. The Meersburg was 5.99 D-Mark. And then you got the Freudenstadt at 409 and the Wildbad at 359. The unit this thing came in was sold at 1,170 D-Mark. And just to give you a reference, that means that this guy would have cost you 2,660 euros or $3,220 in those days. So when people bought these things, they invested in them. They didn't just buy them, chuck them aside. These were prized units. Makes sense. That's all the entertainment that you had in those days. It was radio. The Meersburg, which is where this chassis comes from, as a full radio, would have sold for 1,360 euros, about $1,650. The Freiburg, nearly $2,000. So these things were expensive, and much, much, much more expensive than the comparable Grundig or Telefunken. Telefunkens weren't cheap either, but there were a few other brands that were a lot cheaper, so more affordable to the common man. And they would have been sold for, a third of these prices. So these things are worth restoring. And but more importantly, what I like about these guys is that there's incredible complexity in the circuitry. Again, it is overkill in some cases, but it's really, really amazing what you learn when you play with one of these. And I'll be doing it one step at a time. I'll end up hopefully with a chassis that's fully working with no woodwork and no speakers. I'm not sure what I'll do with it then, and I really don't care. The experience is what I'm after, and that's what gives me satisfaction. So I'll decide later what I'm going to do with it. But in the meantime, I'm going to get started, and I'm not going to follow a very different method to what I've done before. This is just a radio, tube radio. It's got the FM, it's got the AM bands, it's got the IF frequencies that are practically the same. The IF chain is practically the same. Even the mixed oscillator tube is the same. It's an ECH81. And then you've got at the end, in this case, you've got one EL84 in single-ended driving the output transformer, which then feeds 2 or 4 speakers. We'll see how that works when we get to it. Other than that, most of the circuitry is very, very similar to what we've seen before. The essential building blocks are all the same. That's how they worked, You don't build a car without wheels. That's how these things work. Now, obviously, there's a lot more to it, and it'll be fun to see how we get into that. When you look at the underside of this thing, you can see right away that this is a different beast altogether, and it should be fun. So if you are patient, if you want to see something different, you might have even seen this, but if you want to get into a different level of project, this is certainly a different level, then stick around, and I hope you enjoy the series. And please feel free to comment below with suggestions, because when I post a video, I normally haven't done the next section of work. So usually what you say can be taken up and used as I continue the restoration. Stick around, hope you enjoy it, and let's get going. The way I normally start a project like this is to try and find a very good service manual. Now, one of the sites I frequent and use as a source is this one. It's nvhr.nl, Nederlandse Vereniging voor de Historie van de Radio. So, Dutch Association for the History of Radio. They've got a very, very good and comprehensive site, and the way I do it is I go to here, schematics, I put in there the brand, and I'm looking for the Breisgau. See what we get. Well, yeah, quite a few of them. And we're looking for the Breisgau 8. I've subsequently learned that Breisgau is actually a town or a region in the area where SABA was set up. Just a bit of information. Here it is. Breisgau 8, 1957. It's a radio gramophone, and it's got a schematic. So we'll go here, and we certainly have a schematic. But not only do we have a schematic, we've got alignment instructions, the all-important dial cord winding, which in this case is actually quite a mess. It's quite a few things, including the rotation of the antenna, of the ferrite antenna. And we carry on, and we've got a description, and actually, I've just realized this one has got English on it as well. Most of them don't, but this one does. Alignment procedure. Here we go. Can't ask for more than that. Perfect. It gives you the procedure for the alignment of the IFs and the RFs, and also for the here's the IF transformers. And now these IF transformers are a lot more comprehensive than the usual. They actually allow you to align the primary, the secondary, which is the usual thing, but also the amount of interaction between the two. So they can allow you to determine the width of the pass band of that filter. So you know that curve, you can make it broader or narrower depending on the adjustment that you make on here. What else have we got? Right, we've got all that, okay? Now, I notice one thing here, and that is that this thing is a little bit hazy. It's not very good resolution. So I've saved that, and I'm going to use this, especially for the alignment instructions, but I went one step further, and I discovered that if I use the Meersburg 8, let's go back here. I know that this radio is exactly the same innards or chassis as the Meersburg 8. There's one more slight change, which has to do with the connection of the radiogram, of the gramophone, but that's not important right now. So if I go to the Meersburg 8, here's the schematic for the Meersburg 8. What do we get there? Aha. Okay, now look at the schematic. And if I zoom in, you see how much clearer that is? That's what I want. So I can use the alignment instructions for the actual Breisgau, but if I want to use the schematic to do all the checking on, this one certainly promises to be a little bit more detailed and more clear, which is what I do. So I download this one, okay? Now, once I've downloaded this one, I've now collected quite a bit of information. I'll show you exactly what it is that I've collected. I've created a new folder for this project. And if we look at what we have here, we've got an old schematic that I found, but it's not that clear. Then I've got this full service manual that I showed you with everything on it, including the rather unclear schematic. What else have I got? I've got the Meersburg 8 one, which again I showed you, and this is the one with the clearer schematic. And then I've got, what is this one? This is the first alignment instructions that I found for the Breisgau 8 automatic, and I kept that as well. But we've got this on the full service manual as well. So the first thing I'm going to do is I want a clean schematic for that Meersburg. And so I will go to this one, which has, it's a PDF with various pages, as you can see. I'll open it with, in this case, I'll open it with my preview app, but you can open it with whatever you want that allows you to edit. And I'm going to delete everything that is not the schematic. So I'll delete those two pages, and I will delete these pages, and I'm left with this, which is just the schematic. Let's see if we can rotate it. And what we have now is just the schematic. I'll save that. And so my Meersburg 8 PDF now just has a schematic, clean schematic. I'll actually just rename it and call it clean. Just so we can distinguish from everything else. And now we can open it with Adobe Acrobat. And with the comment function here, it gives me the markups and the drawing tools, and now I can do my usual business. And of course, this is the schematic that I'm going to work with to do all the painting in, marking in the lines of everything I've checked. And so this is the start really to everything. There's quite a bit of preparation, but the one thing you'll notice is that if you don't do this, everything becomes more complex. So it's better to do this right at the beginning, especially for a project of this nature. It's quite a busy project, and when you look at it like this, it starts to make sense as well. So that's where everything begins. Now, after having a look at the schematic for a while and trying to get a feel for what you're looking at, we start with the radio itself. And I've got to tell you, I've done a little bit of work on this already, as you can probably see by the transformer, but this is what I do first. I take out all the tubes, and in this case there are quite a few. I think there's 10 if I'm not mistaken, including the magic eye, which I wrapped the socket in some tape so we don't get any short circuits. Now obviously no power's gone onto this yet, but we prepare everything for the first stage of this testing. Then what I did is I had a look at the power transformer. Now this is quite a hefty one, but it doesn't mean that it can't blow. It could be blown. So I do a quick test. It's a sort of safe way of testing a power transformer, and I've done a separate video and put it into the building block section of the channel. I'll link it above, and that allows you to check whether the power transformer is operational. That's very important, because if it's not, these things are not easy to come by. They can be expensive if you can find them. But I did the test on this one and it seems to be okay. The next item you've got to check for operation is the output transformer. It's as important, if not more important, than the power transformer, because this was really very specific. And if you don't find that this is operational, you've got a problem. But fortunately, as far as the quick test is concerned, and again I'll link it above, the way to do that, this thing seems to be operational as well. And then you just start from the beginning. You look at the schematic, and the first thing you have to look at is the power coming in. And we found this thing had the power cable cut, which is always a good idea when you're shipping out old radios. It's just to avoid someone just plugging it in. So this one had been cut, and it was a 2-wire cord, as you can see, that brown cord there. So what I did was I got a 3-cable cord, a 3-wire cord, which allows me to have the mains earth as well. And I connected that to the existing cord. You could actually go one step further and actually solder it into the inside there, but it's not necessary. This thing fit nicely. I soldered them together, put heat shrink wrap, protected both wires, and then put some heat shrink wrap around it and connected it, or screwed it on with the cable tie over there. And the one extra wire that came out, and I don't know if you can see that, it's that curved one. That's also got heat shrink on it just to get rid of the green. It's the earth connector, and that is screwed on to that holder there. So we've now got our chassis connected, nicely connected to mains earth on the power line. Then you go one step further and you find that both of those go to the switch, and the switch is that thing over there, and you need to check if it's operational. And I checked that it was operational, and indeed it is. It also has 2 capacitors. They're supposed to be safety caps, but they're not. They are just the normal paper caps, and they were in pretty bad shape. So I replaced them with safety caps. Schematic calls for 2 5 nanofarad capacitors to earth ground, to chassis. I had 2.2s, so I used 2 in parallel, and just put the heat shrink on just to hide the just too modern look that this thing would have. So it just looks a lot less obvious. And we carry on with the schematic, and we find that it has another safety cap or filter cap inside on the secondary of the transformer. And there I had to use again 2, because it's a 25 nanofarad. I had 47s, so I used 2 in series. They're both safety caps. That's okay. And this is what those components look like. These are the 2 that I that they had on the incoming mains. They haven't broken apart, but they don't look pretty good. And this one is the one on the output. And look at this thing. It is just melted completely. So that thing was either gone or about to go. So you definitely need to get rid of that. Another thing I changed was the fuse itself. It was blown. Probably to do with that capacitor we've just seen. Probably leaked and drew too much current. So that was replaced. In this case, they tell you that for 220 volt operation, you need a 0.5 amp fuse, which is what we have there. And then you just keep going. And then the first thing you find is the selenium rectifier, that thing over there. Now, this thing looks like it's in pretty good shape. You normally should change them. What I tend to do is leave them till the end, see how the voltages are, because this thing does drop some voltage. If I put some diodes on there, the way some of these caps might be inside here, this thing could just over voltage everything and cause more damage. So I'll leave it there for now. And after those, we have the filter caps that come into the circuit. And the first two are found inside this can. This is 2 by 50 microfarad high voltage capacitors. Now, I am not even going to test them, or I didn't even test them. I took it out and I ripped the guts out and restuffed them with 2 new capacitors. You can sort of see where the work was done on the base of the capacitor, but it's a pretty good result. And of course, this one is slightly different to most. The actual can doesn't make contact with the chassis. The ground, or the negative connection of the capacitors, is connected to the can. But this thing is insulated from the chassis, and there's actually a solder tag on the right that you can see there. That phenolic insulator keeps it away from the chassis. Now, it does not mean the chassis is not ground. It is. What they're trying to do is to get the ground point to where it won't create any kind of earth loops, which is what the black wire is doing. So we just follow that, respect that as well. And I didn't even test that capacitor, but the new ones are just spot on. 47 microfarads, 400 volts each, and they fit in there quite well. Again, I'll link to a video in the building blocks that shows you how I stuff these cans. And between the 2 filter cans, we've got a resistor, which I discovered is that black one over there. I think it's 200 ohms, yep, and it measures just fine. And then there's another resistor, 1.6K, between the second filter cap and the third filter cap, which is at 32 microfarads. And that one was completely open, so I replaced that as well. This is 2 3.3Ks in parallel. That gives us 1.65, and the original resistor was 2 watts. This is 2 watts each, so we've actually got a 4 watt in there. And finally, we have the last filter capacitor on that chain, which is a 32 microfarads. That is connected up here, and I've replaced that with a 47 as well. And I should have used a 33, but 47 is fine. It just does filter a bit more, but it's pretty small and it fits up here just perfectly. So that's the last filter can or filter cap that I've replaced on this radio. And that means that I think I'm ready to power this up and see if we get the B plus voltages and if we get the heater voltages. Now, I'm fairly confident that it's safe because I've removed all the tubes and I've removed the obvious leaky caps that could have created excessive current. Both the filter caps and those small RF filtering that happens there on the primary and the secondary, those would cause a problem if they were shorted. But I'm pretty confident that that danger's gone. The other thing is I'm going to add it or connect it to the dim bulb tester, and I'm going to put it on maximum restriction. So I'm only going to put one 40 watt light bulb in series. That limits the current dramatically. So when we switch it on, that thing should glow and then dim as the capacitors charge up. And if we've got any shorts, that glow will stay very bright for a while or forever. So we can switch that off quite quickly. So I'm going to set this up and I want to power this up. There are no tubes. We're not going to hear anything. We're not going to see much except perhaps the dial lamps. And this whole automatic tuning thing here is being completely ignored for now. However, it's a lower voltage winding on the transformer, so I'm hoping it won't cause anything too dramatic. But we will see what happens when we switch this on, and we will see the dim bulb tester glow. It'll give us an indication if we've got some dangerous conditions or not. So let me set that up. I've got things set up. I think I've got everything I want to read. The big brother is reading the first B+, in other words, after the first filter caps. And little brother is reading it's the heater voltage, so I'm expecting about 6.3 volts AC. I'm expecting it to be, hell, if this thing switches on and doesn't keep that light on all the time, I'm expecting it to sort of be a little bit high because there's no load. There are no tubes, so current draw will be very small, but enough waffling. Let me switch it on. Now watch that lamp there, the first lamp. See how dramatic that was? Not at all. The on-off switch here needs to be activated, so we'll give it that. Brilliant. Okay. On-off switch is on. There's a dial lamp under the whatever band is selected there. This thing's got individual little light bulbs to illuminate the one that you press. Just one of those bells and whistles I mentioned on this sort of set. That thing there went on and then dimmed, so that means the filter cap's charged and it's not leaking much current. So we've got a few dial lamps pulling some current here. We've got the capacitors as well, but that shouldn't draw much. But we've got the that second winding, the one that's going to control the automatic tuning. That's obviously drawing some current, and what we're getting is 6.8 volts AC on your heaters, which isn't bad for no load condition. And we've got nearly 300 volts DC as our B+. Good, so far so good. Let me read the other B+, or the other positive voltages. And that would be, see, where would they be? They'd be after the second, on the second filter cap. That should be pretty much the same because very little current's being drawn through that 200 ohm resistor. And then finally the third filter cap, just slightly lower, because again, not much voltage drop is happening across that 1.6K resistor that I swapped over there. Now folks, this is a very, very good start. This is good news. It means that you haven't got a fire started in the house. It means that your radio is, let's call it viable for renovation, because whatever is messed up, I'm sure you're fairly confident that you can find the problem. And the one thing to bear in mind is precisely what we've been looking at. It's this. Let's do it there. This over here, okay? B+. This thing has got some serious voltages. As you saw, the one that I measured after on the first filter cap was even higher. It's near on 300 volts. It's DC. And more importantly, the transformer is huge. It can supply an incredible amount of current on this level. So you have to be extremely, extremely careful. And also, if you're not aware of the dangers, just stay away. Watch somebody else do it. You can kill yourself, okay? You can kill yourself. And it's not fun when you get zapped by that, all right? I'm speaking from experience. I'm still here to talk about it, but it could be different. Believe me, it could be very different. So if you're embarking on this sort of thing, be very, very, very careful. Learn as much as you can before you start playing with high voltages. It could save your life. Well, folks, that's it for the first video. I'm going to sign off now, and I'm going to carry on doing the checking of continuity and component values and everything else as I usually do. The obvious task is to get the power supply, the power section completely checked, and there are a lot of places to check for that. I'm going to switch this off. It makes me nervous, and I've done dozens of these. All right, see that? I switched it off. It's still dropping very slowly. Voltages get held in those caps for quite a while, so you can still get zapped even though you switched it off. All right, so first things first, power supply. Check the power supply, make sure that the voltages are arriving where they're supposed to on the various tubes and various other parts of the circuit, because the first goalpost is to supply an audio input at the auxiliary input of this thing. Because you've got an auxiliary input at the back, you could connect a record player or a tape deck or whatever you wanted, and it's the cleanest route through the power section, the audio section, to the power amp. So the first task would be to get to the point where we check the audio stages, and we can send a signal, an audio signal in here, and hear it at the speaker outputs. That's probably a little way off, but I'll keep at it and report back to you as progress occurs. Well, thanks for watching, and if you've enjoyed that, click like, share, subscribe, and all that jazz, and I will see you again soon for another video in this series, and perhaps some other topic before that. Thanks for watching, bye for now, and stay safe.